In this video, we'll talk all about functions. Before we dive into creating functions, let's explore why they're necessary in the first place. Let's say I want to write a bit of code that prints my name. So I'll have a constant called first name. I can set it to my name. And I'll have a constant called last name and set it to my last name. Notice I'm using type inference here by not explicitly declaring the data type. And what I'll do is print using string interpolation, hello, to inject my first name and last name constant into the string. And if I hit the play button, Swift is going to execute these 3 lines of code, and you can see in the console is the output. All right, that's perfect. Say I really like these 3 lines of code, and I want to repeat their functionality in different parts of my application. How would I do that? Well, with what we know right now, the only way to really do this is to copy and paste. So I can literally copy and paste, copy and paste, and copy and paste, and keep on copy and pasting to repeat the functionality of those 3 lines, creating 2 constants here and printing the interpolated string. But this is really bad, because in software development, we typically want to avoid copy and pasting. In fact, developers have made it a principle to follow, and that principle is called the Dri Principle. And Dri is an acronym that stands for Don't Repeat Yourself. You might hear me repeating this a lot to don't repeat yourself, but it's important. Instead of copy and pasting our 3 lines of code over and over again, what we can do is associate these 3 lines with an identifier. And every time we use that identifier, we would execute these 3 lines of code. And that's exactly what a function is. So let's start to define our function. To define a function, we use the func reserved keyword followed by the identifier for the function, which is the name that you'd like the function to be. I'll call this print name. After that, we indicate the input we would like the function to have. In our case, we don't need an input right now, so I'll just have an open and closing set of parentheses. And finally, we indicate the block of code we would like to associate with the function with an open and closing set of curly braces. And inside of these set of curly braces, I'm just going to I'm commenting out these 3 lines and pasting those 3 lines of code. And this is our function definition, where we associate this block of code with the print name function. If I click on the play button, notice that there's nothing on the console, because when we're defining our function, we're not actually executing any code. To actually run the code that is in line 12, 13, and 14, we need to call the function. This is called invoking the function. And to invoke the function, we simply use the function name followed by the open and closing set of parentheses. This parentheses is very important because it allows Swift to differentiate between a constant name and a function. So I can have, for example, a constant named this. And if I just use the identifier as is with no parentheses, Swift would think that this is a constant or variable. Now I'm going to delete this and going to hit the play button. And now you can see an output in the console. This is one invocation of our function. And I can copy and paste this invocation as many times as I would like and hit the play button again. And you can see here are 5 invocations of our functions. Every time we invoke our function, this block of code is executed. Functions are great because in production level applications, functions can be hundreds of lines of code, and having a function can save you a lot of copy and pasting. Another benefit of having a function is because we centralize our code here, if we make a change to our function, say I want to put a smiley face, I can hit the play button again, and we can see here the smiley face is incorporated in all our invocations. Alright, as it stands, my print name function is only printing my name, which is pretty limited in its usefulness. Let's create a different print name function that can take input, and depending on what input it's given, it would print a different name. To create a function with input, I'm going to use the func reserved keyword followed by print name. And this is the part where we need to put something inside of these set of parentheses. To define an input for the function, I would start with the name of the input, so I'll call this first name, and the data type of that input, which we mark with colon, the data type. In Swift, a input to the function is called a parameter. So first name is a parameter. And functions can have multiple parameters. And what you would do is separate them by a comma. I can have another parameter called last name, and it's of type string. And that's all I need for now. Next, I'll have an open and closing curly brace to indicate the block of code to associate with the function. And instead of hard coding the first name and last name as I did in line 12 to 14, I'm just going to take the input that is given to the function and inject it into the print function. So hello, first name, last name. All right, so we've defined a function called printName with two parameters. The first parameter is called first name, that is of type string, and the second parameter is called last name, and its data type is also a string. In Swift, between the opening and closing set of parentheses, we call this the parameter list. If I hit the play button, you can see there's nothing new because I haven't invoked the printName function yet. Now, to actually invoke the function, meaning we're going to run the code that is in line 26, we are going to write the name of the function, print name, and because this function takes input, we're going to write the names of the parameter that we define, followed by the values we will be passing in for those parameters. So for example, John is the value we're going to pass for the first name parameter, then a comma, last name, that is the label for the second parameter, we'll pass in Smith. And when we execute this line of code by hitting play, you can see hello John Smith in the console. What line 29 is doing is passing the value John and assigning it into a constant called first name, and passing in a value called Smith and assigning it to a constant called last name. And in the body of our function, we will be using the values that were passed in for first name and last name and use it in this print statement. And the beauty of this is I can actually have different inputs. So Alicia Jones, Kyle Anderson. Hit the execute button. You can see in the console there are 3 different print statements which are using the parameters that are passed into the print name function. Alright, so that is defining and invoking a function with input. Finally, functions can generate output. Let's create a function that can add 2 numbers and return the output. So in order to do that, I would create a function called sum, and let's say it takes a number called x. The data type of that number is int, and it takes another parameter, that data type is int. And in order to indicate that this function is returning a value, I need to use the dash less than sign. And I need to indicate the data type that is returning, so it's returning an integer. If we were to read through line 34, we would see that we're creating a function called sum. It has a parameter list of 2 parameters. The first one is x of type int, the second one is y of type int, and the dash less than sign is indicating that this function has an output, and the output is of type int. Now inside the body of the function, we need to actually return the output, and we do that by literally using the return reserved keyword followed by the data we want to return. In this case, I'm returning the result of x plus y. Return is a very special reserved keyword. It will immediately exit the function and return whatever value is on the right side. So if I have any code after the return keyword, it's not going to execute. And if I hit the play button, the warning would tell me just that. The code after the return keyword will never be executed because in line 35, the function will stop and whatever value is after the return keyword will be returned as the output of the function. Let's call this function to see what we get. I'm going to call sum followed by x10, y20, and if I run this, you can see that the output is 30. What we can do with functions that return values is typically capture them in a constant or variable. Let's say I want to call this result, and we typically reuse them. So let's say I want to print the result is result. And if I hit the play button, you can see that the output of this sum function is captured in this result constant and it's reused in this interpolated string, and you can see right here. So when we define a function with an output, there's two parts you need to pay attention to. The first part is defining the data type that will be returned, and the second part is in the body of the function actually returning the value. And later on, when you're invoking the function, you can use the return value and store it in a constant or variable and use that in other parts of your application. And that is it for functions. They are an incredibly useful language feature to have around. They allow us to not repeat ourselves by reusing blocks of code. Functions can also have inputs, which we define as a parameter list, and they can also have outputs in which we return values from.